We're solving problem 19 from the 2023 F equals MA exam. A student sets up a simple pendulum, measures its length to be 0.5 plus or minus 0.01 meters, and observes a period of oscillation of 1.4 plus or minus 0.1 seconds. Using this data, the student computes G is equal to 10.1 meters per second. What is the uncertainty of this measurement? So if we have this pendulum here, gravity is the force going down and T is here, and this is the length. Well, the time of this period, we can write that as 2 pi times the square root of L over G. This means that G is equal to 4 pi squared times L over T squared. Now, you also have to consider the ratios of gravity. So, in this case, we have to do change of gravity over gravity is equal change gravity over gravity. This is uncertainty calculations. This is the square delta L over real length squared plus the time's down there, by the way, so it makes a nice triangle. Delta T power negative 2 T to the power of negative 2, and then you square that. Now, you have to consider this case where the powers are negative. And this is because we can write it dividend. We're both power negative 2 as the absolute value of negative 2, and then it's just the ratio of delta T to the time, actual time. So delta T over T. And absolute value of negative 2 is simply 2. You can multiply this G over to get what we're trying to solve for, change in gravity. This is equal to G times the square root of delta L over L squared plus 2 delta T now, because you multiply by 2, and then you square that, and then take the absolute value of that. So we've compiled a formula for the change in gravity, where all you have to do now is plug in the values they got. So the oscillation is 0.4 plus or minus 0.1 seconds. The length is 0.5 plus or minus 0.01 meters. And G is equal to 10.1 meters per second. So using that information, we can find the change, and we can solve for delta G, the uncertainty, to be 1.4 meters per second squared as our answer once you plug everything in.